We looked at size exclusion chromatography in our last lesson. Let's look at some column chromatography techniques that are more effective at accomplishing protein separation. Affinity chromatography is very highly specialized and can provide a means of purifying a protein to a high degree in a single step. In this method, the column material or stationary phase is a solid bead with a substance linked to its surface. We would choose a substance to which our target protein would bind, and none or few of the other proteins in solution. When the sample is applied to the column and the mobile phase added, almost all of the contaminating proteins would pass straight through, and only our target protein would bind. All that remains is to elute our protein from the column, typically by adding a solution containing a soluble form of the substance to which it binds. Another powerful type of chromatography is referred to as ion exchange. In this case, molecules are separated based on net charge. Cation exchangers are resins that carry a net negative charge, and only molecules carrying a net positive charge will bind. Anion exchangers carry a net positive charge and will only bind oppositely charged molecules. Note that in each case, what is exchanged is the molecule bound to the column. Cations or positive particles in the first case, and anions or negative molecules in the second. Let's look at an example of cation exchange. We will choose an initial pH that ensures our target protein carries a net charge that is opposite to that of the resin. For this purpose, we need to know the pI or isoelectric point of our protein. Recall that this is the pH at which our protein has no net charge, in which case it could not bind to the column. Having properly selected our pH, our protein will bind to the resin, and proteins carrying the same charge as the resin, or those that are neutral, will remain in the mobile phase and flow through. Now that the contaminating proteins have been removed, we need to displace our protein from the column. The most common method is to add a high salt solution. The abundance of ions of small size, and opposite charge to that of the resin, will readily bind the resin and thereby displace our protein. Let's look at an application of this technique in separating a mixture of the amino acids aspartate, serine, and lysine. Recall that this is cation exchange, so our resin carries a negative charge. Of these three, the amino acid carrying the greatest positive charge will bind more tightly than the others and will elute last. In this example, aspartate has a net negative charge and doesn't bind at all, hence it will elute first. Next comes serine, since it has a net charge of 0 at neutral pH. Lysine elutes last because it has a net positive charge due to its side chain. Another effective technique is HPLC, High Performance Liquid Chromatography. This is a very fast and effective technique and separates based on polarity. Reverse phase HPLC is a modification of HPLC that also separates based on polarity. It has a nonpolar stationary phase and a polar mobile phase. These are very high resolution columns, and the separation can be accomplished in less time. As you can see, there are many different methods that can be employed to accomplish protein purification.